Hi children, how are you all? I hope all you are fine. Children, in that previous video what we discussed we discussed up to that representation of addition and multiplication on a number line. Now here in this video we are going to discuss about that properties of whole numbers. Okay. Now here see that properties of whole numbers. Here we are having that some properties What are those properties? First see here. The first one is closure property. What is that? Closure property. Second one is commutative property. Commutative property. Okay. Next, third one is associative property. Associative property. Next one is distributive property. Distributive property. Next one we are having that role of 0. Role of 0. Next one role of 1. Okay ma, these all are the properties which are related to whole numbers. Okay, one by one property we will learn. See that the first one is a closure property. What is that ma? Closure property. In closure property, see that the first one is the closure property. What is the condition of that closure property? See that let A comma B are any two whole numbers. Any two whole numbers. Any two whole numbers. Then A star B is also a whole number. A star B is also a whole number. A star B is also a whole number. Understood ma? See that let A and B are any two whole numbers. Take that any two whole numbers. Okay. Then here A star B is also a whole number. Here star means what? Star means here star be a fundamental operation. Star be a fundamental operation. Fundamental operation, which means here plus, minus, multiplication and division. Understood ma? Which means here A star B, we can take this one as A plus B, A minus B, A into B, A divided by B. Understood? Now here see that here A and B are whole numbers, we know that. If you add those two, then also we will get it as a whole number, then that property satisfies. Otherwise property does not satisfy. And in the same way A, B are whole numbers, right? If you take that addition, then the sum must be a whole number, then only this one satisfies. And in the same way the difference of whole numbers also must be a whole number. In both cases, actually we can observe here two cases. Okay, in that all cases also we will get that whole number, then here that property satisfies, otherwise does not satisfies. And in the same way here multiplication and division also. Understood? Okay, now here say that first addition. Under addition, what is that condition ma? A comma B belongs to whole numbers, then A plus B is also belongs to whole number. This is a condition. Am I right? Now here this condition satisfies or not, just we are checking here. Understood? By taking that example, let checking, let A is equals to 2, B is equals to 3. Okay ma? 2 and 3, those two are whole numbers or not? Of course 2 and 3 are whole numbers. Okay. Now here A plus B is equal to 2 plus 3, which is equals to 5. 5 is a whole number or not? Of course that is a whole number. Understood? Which means the sum of any two whole numbers is also a whole number. Then we can say that closure property, whole numbers are closed under addition. Whole numbers are closed under addition. Okay. And in the same way, by taking that subtraction, second fundamental operation, what is that ma? Subtraction. Subtraction, here see that here again the condition a comma b belongs to whole numbers, a minus b belongs to whole numbers or not. Okay, that condition just we have to check it. Let a is equals to 2, b is equals to 3. You are wish any number you can take here. Two cases also I will explain here. See that this is case 1. Here a minus b is equal to 2 minus 3. Children, here this is related to integers. See that one positive and one negative. Here minus is there, no? Just whenever we are subtracting a big number from the smallest number, then always keep that negative symbol here. Okay, when we are subtracting a biggest number from a smallest number, then always the difference is negative. Understood, ma? Then here 3 minus 2 is equal to 1 only, no? Then answer is minus 1. Minus 1 is there in that whole number set, ma? In that whole number set, minus 1 is not there, no? That's why here minus 1 does not belongs to whole numbers. Minus 1 does not belongs to whole numbers. Then here what we can say here, a minus b does not belongs to whole number, which means that property is not satisfying here. Okay, in some cases that is second one, let a is equals to 4, b is equals to 2. Okay, a is equal to 4 and b is equals to 2. Now here take the difference of a minus b. Then what we will get here, 4 into those two are whole numbers, no? Now here a is equal to 4, b is equal to 2. Then here 4 minus 2 is equals to 2. Okay, children. Now here see that a minus b is equals to how much you got, ma, here? That is 2. Now here 2 belongs to whole number. Okay, which means here in one case that is satisfying, in that another case that is not satisfying. What we told, ma? Here property satisfies means in that all cases it should be satisfies. But here in that one case it is satisfying, but in that another case that is not satisfying. Understood? That's why here what we can say that whole numbers are not closed under subtraction. Understood, ma? Next see that multiplication. Multiplication. Multiplication condition, what is that? A comma b belongs to whole numbers, then a into b is also belongs to whole number. Understood? Now here let a is equals to 6, b is equal to 5. Okay, here you can take that any two numbers. Any two numbers always you will get it as a whole number only. See that? Now here a into b is equals to 6 into 5 is equals to 30. 30 is a whole number or not? Yes, of course 30 is a whole number. Then here a is equal to 0, b is equal to any number. Then also you will get it as 0. 0 is a whole number or not? Yes, of course. Okay, in all cases multiplication also satisfies. Okay, ma? And finally we are having here division. What is that? Division. What is that condition? A comma b belongs to whole numbers, then a divided by b belongs to whole number. It is satisfying or not? Okay, just to say that here also two cases are there, ma. Let a is equals to 4, b is equals to 2. Then a divided by b is equal to 4 by 2 is equal to 2 ones, 2 twos. Then here we are getting that 2. Understood? Now here a divided by b belongs to whole number. In another case, let a is equals to 2, b is equals to 4. Now here a divided by b is equal to 2 divided by 4. 2 divided by 4 means 2 by 4 only, no? Then here 2 ones, 2 twos. Finally what is that answer, ma? 1 by 2. 1 by 2 means that is which kind of number here? Whole number only, no? 1 by 2 is belongs to whole numbers. Sorry, 1 by 2 is it belongs to whole number, ma? That is it does not belongs to whole numbers. Understood? Why? Because here 1 by 2 is a fraction. Understood? That's why here 1 by 2 is belongs to rational number, not whole number. 1 by 2 is belongs to rational number. But here we need to get that whole number, no? That's why here 1 by 2 does not belongs to whole number. Understood? That's why say here in one case that is satisfying, one case that is not satisfying here. Understood? At that cases, what we can say here, division also not satisfies. And finally, what are the statements here? Finally, two statements related to closure property, ma. What are those two statements means? Finally, here whole numbers are closed under, closed means closed property, closed means closed property, closed under closure property. Closed under which fundamental operations, ma? Addition and multiplication. Addition satisfies, and in the same way multiplication also satisfies, no? Addition and multiplication. That's it. And in the same way, not closed under, whole numbers are not closed under. Closed means closure property, already I told you, no? Not closed under. Which two fundamental operations not satisfying, ma, here? Not closed under subtraction and division. Subtraction and division. Understood? Children, see that finally here two statements. Here whole numbers are closed under addition and multiplication, and in the same way not closed under subtraction and division. Understood, ma? Yes. See here. So this is about that closure property, and this is the condition of that closure property. What is that condition here? Let A comma B are any two whole numbers, then A star B is also a whole number. And here star means any fundamental operation. Out of 4 fundamental operations, one fundamental operation just we have to perform it. Understood, ma? So this is about that closure property. Closure property, after that, which property is there? That is a commutative property. Okay, next one, say that. What is that next one? Commutative property. Second one, commutative property. Commutative property, another name also there, ma, that is order property. Another name of commutative property is order property. By seeing the name only, we will, I think so you got that clarification, order property, which means order. By changing the order also, we will get the same result. Understood, ma? See that. Let A comma B are any two whole numbers, any two whole numbers, A comma B are any two whole numbers, then here the condition is A star B, which is equals to B star A. Understood, ma? The condition is A star B is equal to B star A. Again here star B a fundamental operation. What are those fundamental operations? Addition, subtraction, multiplication, division. Addition, subtraction, multiplication and division. Understood, ma? So these are the star values. Okay, at the place of star, just to take that any one of the fundamental operation. Now here checking, say that first under addition. Under addition, first check this one. Here what is the condition? A comma B belongs to whole numbers and A plus B is equal to B plus A. Is it satisfying or not? Checking value, see that. Let A is equal to 5. B is equal to 7. A is equal to 5, B is equal to 7. Now here A plus B is equal to 5 plus 7 is equals to 12. Yes or no, ma? Yes. And in the same way B plus A. B is equal to 7 plus A is equal to 5, which is equals to 12. From this one, what we can say here? If we change the order of the numbers, then also we will get a same number. Then also we will get a same result. When it is, if you will take that addition, by adding any two numbers in any order, by adding two numbers in any order, always we will get the same result. Understood, ma? Which means if you change the order of the numbers, then also you will get the same result only in all cases. Understood? That's why here, finally what we can say here, A plus B is equal to B plus A. Then here whole numbers are commutative under addition. Whole numbers are commutative under addition. Why? Because this condition is satisfying, no? That's why. Understood, ma? Next one is subtraction. Under subtraction, see that. What is that condition? A comma B belongs to whole numbers. Now here A minus B is equal to B minus A condition. Is it correct or not? Is it satisfies or not? Just we have to check it. Understood, ma? Now here see that. Let A is equals to 4, B is equals to 2. A is equals to 4, B is equals to 2. Now here A minus B is equal to 4 minus 2 is equal to 2. Okay. Now here B minus A is equal to, B is equal to how much, ma? 2. A is equal to minus 4. Sorry, A is equal to 4, no? That's why here 4 and here in that middle we are having that minus. Then here 2 minus 4. What I told you, ma? When we are subtracting a biggest number from a smallest number, then the answer is always negative. Okay. Then here 4 minus 2 is equal to 2. Minus 2. Minus 2 is there in that whole numbers. In the set of whole numbers, can we observe that minus 2? Minus 2 is not there in whole numbers. Minus 2 is related to that integers. Okay, ma. That's why here minus 2 does not belongs to whole number. Okay. And in the same way, here we can say that one does not belongs, and in the same way final statement also we can say that A minus B is not equals to B minus A. Why? Because 2 is not equals to minus 2, no. That's why the condition is A minus B not equals to B minus A. Which means when we are performing that subtraction, we can't change that. If we change that order of the numbers, then we will get the different results. If we will get the same result, that one happens in that only addition. Okay. And here subtraction not possible. Next we have to check that multiplication. Multiplication satisfies. Okay. If it satisfies or not, just check that. Next one is multiplication. Okay, ma. Let A comma B belongs to whole numbers, then A into B is equals to B into A. B into A. Okay. Now here let A is equals to 2, B is equals to 3. Then here A into B is equal to 2 into 3. Yes or no? A into B is equal to 2 into 3. 2 3 is how much, ma? 6. Clear? Next one B into A, which is equals to B is equal to 3 and A is equal to 2. 3 2s is equal to 6. Understood? Now here see that finally what we can say, A into B and B into A having that same value. Then here finally we can say that A into B is equal to B into A. Understood, ma? So it is satisfying or not? Yes, this is satisfied. So what we can say here, whole numbers are commutative under multiplication. Okay. And finally we are having the division. Okay. Now here A comma B belongs to whole numbers, then A divided by B is equal to B divided by A condition actually. That one satisfies or not, just check it. Let A is equals to 2, B is equals to 4. Okay. Then A divided by B is equal to 2 by 4 is equal to 1 by 2. This is also not related to whole numbers, and in the same way we can say that B divided by A is equal to 4 by 2. B is equal to 4 only, no, and A is equal to 2. Then here 4 by 2. 2 1s, 2 2s. Here we got that answer as 2. But here we can say that 1 by 2 is not equals to 2. Yes or no? And finally, what is that statement we can say here? Here we can say the statement as A divided by B is not equals to B divided by A. That one is not satisfying, no? That's why. Understood, ma? Now here see that A divided by B is not equals to B divided by A. And finally, what statement we can say here? Whole numbers are commutative under which fundamental operations ma? Addition and multiplication. Addition and multiplication. Okay, and in the same way whole numbers are not commutative under subtraction and division. Subtraction and division. Understood ma? So this is about that commutative property. Commutative property condition is here A star B is equal to B star A. Here star B any fundamental operation, for which fundamental operation this is satisfying, that property also satisfies that fundamental operation. As per that one, what are the two statements ma here? Final statements are whole numbers are commutative. Commutative means commutative property satisfies. Whole numbers are commutative under addition and multiplication. And here whole numbers are not commutative under subtraction and division. These two are the final statements. Understood ma? So children, this is about that commutative property. In this video, what we learned ma? About the closure property and commutative property we learned, right? In that next video, we will discuss about that leftover properties. Okay, thank you all.